The Raspberry Pi is a small single-board computer that was developed in the UK by the Raspberry Pi Foundation in order to promote teaching of basic computer science in schools and developing countries. It is very inexpensive, and with the latest model for only $35, you can get an entire computer on a single board complete with Wi-Fi and Bluetooth functionality built in. Since the release of the first version in 2012, the popularity of this board, especially in education, has skyrocketed. So, what can you do with a Raspberry Pi? You can install an entire operating system and use it as a fully functioning computer, allowing you to edit documents, surf the internet, program computer software, and use it as a day-to-day computer. It runs a variety of Linux distributions, with Raspbian being the most popular, which is what we will be installing in this course, and it even has a Windows distribution, Windows IoT Core, which runs on it. Okay, great. You may say, but what exactly can you do with it, you may ask? Well, because of the GPIO pins, which provide the ability to connect and interface with external sensors and electrical components, it can be used in robotics and prototyping projects. You can also use it for home automation and industrial automation. You can also set up your own gaming system to play older Nintendo, Super Nintendo, Sega, PlayStation games via emulation software, and you can set up a media server to stream and play your digital movies, music, and online content. The possibilities are endless, and we will learn some of these applications in this course. Now, let's take a look at the Raspberry Pi 3 Model B, which is the model we will be using for this class. You can certainly do the class with earlier models, but you'll need a Wi-Fi dongle to get connected to the internet with version 2 models and earlier. Alternatively, you can use a hardwired networking connection via an RJ45 networking cable. The earlier versions will also not be as fast as the version 3. Here is a rundown of the Raspberry Pi version 3. The CPU uses 64-bit quad-core architecture and runs at 1.2 GHz, and this can be overclocked. It has a 1 GB of memory. It has 4 USB ports, which enables you to connect to peripherals like a mouse, keyboard, microphone, and speakers, etc. There is an HDMI connection, allowing you to connect to a monitor or TV for displaying content. It also has built-in Wi-Fi and Bluetooth capability, allowing you to easily take your projects into wireless mode. It also has an Ethernet port to allow connections to traditional RJ45 network cables for wired connectivity. There is a 15-pin MIPI camera interface connector that can be used with a Raspberry Pi camera. There's also an analog audio port that works with a 3.5mm jack. And it has 40 GPIO pins, or general purpose input-output pins, that can be used to interface with your electronic components and sensors. A power connector is also present, as it requires 5 volts to operate. And it also uses a micro SD card slot, which is the onboard storage. The SD card contains the operating system. We will be talking about how to get this all prepped and loaded to run your operating system. That is quite a bit of power and functionality on a single board for only $35. So now that we have an idea of what the Raspberry Pi is and what it can be used for, in the next few lessons we will look at how we set everything up.